Good morning, mathematicians. We are finishing out our week 12 Thursday column to finish out this week 12 today. And we are getting really good at these style questions. This says write an expression to find how much of the square is shaded. I'm going to look at the rows first. How many rows do we see? One, two, three, four, five. So my denominator is 5. And how many of those rows have some shading? 2 have shading. So our first factor is 2/5. We see it in the rows. Now let's take a look at our columns in order to find our next factor. How many columns do we have? One, two, three, four, five. We also have a denominator of 5 in our columns. So we know that our second factor is also going to have a denominator of 5. Now, how many of those columns have some shading? One, two, three. This is a good reminder. Of course, it doesn't have to be the entire row or column that is shaded, but if we see it in a portion of that, we go ahead and count that for the denominator, or excuse me, for the numerator. So our answer here is 2/5 times 3/5, but that is the same as 3/5 times 2/5. We could have either of those and count those correct. They are the same expression showing the same area. Let's use similar thinking for this question. This is really our last question like this area question um, for the week, right? So let's think about this as we're looking at our rows. The very first thing that we're going to think about with this factor is our rows. How many rows do we see? One, two, three, four. So I will have a denominator of 4. Now, how many of those rows have some shading? 3 of the 4 have shading. So we're seeing 3/4 as our first factor or second. You can do these in either order. Now we're going to look to the columns. How many columns do we see? One, two, three, four, five. So I know I have a denominator of 5. And how many of those columns have shading? That would be 4. So we see 4/5 as our next factor. We could list these in either order, but we are seeing that same idea of representing the square, the shading of the square as an expression, which is really the heart of this math skill. Now, let's take a look. We have one more volume question for this week, but this volume question requires us to actually use a different strategy in order to do it efficiently. I don't want to separate this into tons of tiny rectangular prisms when instead a more efficient strategy would be to calculate the volume of this entire prism as if it didn't have a hole in it, and then calculate the volume of this prism, the missing space, and we will subtract the volume of this from the overall volume of the entire prism. So we're going to be thinking a little bit and compensating as we go. So we're first going to find the volume of this entire prism. It has a length of 6. It has a width of what? Make sure you're really analyzing these dimensions. Here's my width. So it has a width of 3. It has a height of 4, right? So now we're going to multiply those things together. And if I stick with 4 times 3 being multiplied together first, then I can use a basic 12 fact, right? 12 times 6 is 72. So I know that if this were an exact prism, the volume would be 72 cubic centimeters, but it's not. So now what I need to do is I am going to find the volume of this prism. So I've really calculated the volume of A as if it were intact. Now I'm going to calculate the volume of the missing part, right? Well, I see it has a length of 5. I see it has a height of 3. What's the width? Well, the width would be exactly the same as the entire prism, so that is going to be a width of 3. Now, if I multiply these together, I have 5 times 9, right? Or I could do 15 times 3, and in either case, I'm going to arrive at 45 cubic centimeters. Where's our answer, boys and girls? Well, our answer is going to be the difference. So we're going to take our 72, that was prism A, and we're going to subtract our 45 that is actually the hole in that overall prism where we're going to find the difference, right? So here, let's go ahead and get started. We have 2 minus 5. I can't do that. So I'm going to borrow from this. I'm going to make that a 6. And I'm going to turn this into a 12. I have 12 minus 5, which is 7. Now I have 6 minus 4, which is 2. So now I have my difference. What I have for the volume of this figure is 27 cubic centimeters. That is what I'm looking at as the volume of this overall shape. Now, as a side note, students and teachers, if you're looking at the key actually has different dimensions that are listed for this prism. So I went ahead and opted for this key to do what's on the student version. But that might be why you're seeing some difference in our calculations. Let's go ahead and take a look at write three expressions to represent the below diagram. So basically, looking at these two tape diagrams, how could I express what I'm seeing in multiple ways? Well, the first thing my mind goes to is looking at this tape diagram and saying, okay, what fraction of the tape diagram is shaded? Well, the tape diagram is separated into 1, 2, 3, 4, 5 parts, and 3 of them are shaded, right? So I see 3/5. And how many times do I see 3/5? I see 3/5 here, and I see 3/5 here. So I see two groups of 3/5. There's one expression that we could list. Now, that leads me to really, where did I get to this idea of 3/5? Well, this is a whole, right? And isn't that whole divided up into 5 parts? That's how I figured out my denominator. I had a whole and I broke it into 5 parts. That was what I did really mentally. And then I knew that what I had of that was 3 of those. But I had 3 of them here and I had 3 of them here. So I could do times 3 times 2, or we could also do just times 6 at this point because we have 3 of them here and 3 of them here. So I'm going to go ahead and show that really it's this, but I have 6 groups of that. Okay, so that's one way that I can do it. The last way that I'm going to show is what is one of these? Well, one of these is 1/5, right? This shaded part is 1/5. And in this tape diagram, how many fifths do I have? I have 3 of them. Wouldn't this show that idea of 3 groups of 1/5 being 3/5? And I really have 2 of those. I have one of them here and I have one of them here. Okay. Now notice I did use some parentheses here. You could also do parentheses here. You don't have to. It's not really going to change the order of problem solving. But certainly you could do that. And that might help someone else to really consider what my thinking was as they're looking at the expressions that I have written. Notice number 5, we did that yesterday. So this finishes out week 12.